models with fine-tuning problems are undesirable, but there's nothing spooky about fine-tuning itself. Fine-tuning is just a consequence of not being able to explain stuff when the stuff has to be very precise. But the fact that precision exists in nature is not spooky. We don't understand enough about nature really to say whether or not it is, but the skeptics among us will say it's not spooky. We'll lean towards that side. So, you can imagine my surprise when, on one of my many voyages across the internet, I came across this gentleman, Dr. William Lane Craig, philosopher and theologian, who was advancing his own version of the teleological argument for the existence of God or some designer. And he was doing so in the context of so-called fine-tuning. Well, I understood fine-tuning. I was a young graduate when I came across this guy. I knew what fine-tuning was because I'd had to study cosmology, and in cosmology there are several outstanding fine-tuning problems. It's the same with particle physics. So I was a little bit confused that this guy thought that fine-tuning, which was something that scientists were doing to their models, could in any way become an indicator of the existence of God. And I decided to check out his argument. And you're just going to have to bear with me. William Lane Craig does a fantastic impression of a stuffy English atheist. It's brilliant. You should check it out. I'm going to have to decline this fantastic opportunity to return him this noble gesture on the grounds that I simply can't live up to his marvelous voice. It is incredible. It has all the qualities of a cartoon character. So I'm just going to use my own stuffy English atheist voice. 1. The fine-tuning of the universe is due to either physical necessity, chance, or design. The Empire Strikes Back. It is not due to physical necessity or chance. This is where the real substance of the argument lies. And thus Craig marches triumphantly towards his devastatingly clear conclusion. Absolutely unavoidable. Therefore, it is due to design. Yeah. That reminds me, actually, I think the toilet might be broken because I kept flushing it, but it just kept popping back up and bobbing around in the bowl. Andrew Copson gets it. Well, let's assess it on its own merits. It's a logically deductive argument. It follows necessarily that conclusion 3 is true from premise 1 and 2. Unfortunately, premise 1 and 2 need a little bit of investigation. We're going to start with premise 2 just to be a little bit quirky, if possible. It is not due to either physical necessity or chance. Now, I've put or in italics. I hope that displays. Because physical necessity and chance are not really separable in this way when you think about it. I mean, suppose you toss a coin and you throw it up to chance. A coin toss is a way of determining something, with a 50-50 chance. And the reason is that you know how many sides the coin has. It has 2, and it has to land on one of those sides. But you also can't predict, in the time it takes to decide a coin toss, which way the coin is going to land. You don't really know enough about the initial conditions, or rather, you don't have enough accuracy. But if you were to replicate the initial conditions of a coin toss, then it would land exactly the same way. In fact, if you could replicate all of the conditions of a coin toss, quantum effects, random effects, would not change the outcome of that coin toss. The coin is too big. So you would be able to replicate the same coin toss over and over again. If you got a machine to do it and you knew the coefficient of friction of the surface it was landing on and you knew everything about the air pressure in the room, you'd be able to recreate it. So is this chance or physical necessity? Well, it's operating according to the laws of physics. Physical necessity, or law, as William Lane Craig sometimes phrases it, is just controlling the coin as it should. There's nothing particularly spooky about it. But let's go to something where we are a little bit more ambiguous about the nature of what's going on. Quantum mechanics. I mean, in quantum mechanics, things occur randomly. At least that's what people always say. But actually, it's not really true, because in quantum mechanics, things still obey laws. It's just that they're characterized by laws of probability, or probability laws. This is an equation. This is a Schrodinger equation, and this is a law in quantum mechanics. It's always satisfied. But it's a probability equation. It gives you a wave, and that wave amplitude is the probability. Now, This is important because, again, the most random things we can think of in the universe, the things that happen at the quantum scale, do obey some kind of law. Is there really such a thing as chance, and can it be separated from law in this way? I don't really think so. I think chance is an illusion, and it's something that we experience because we can't predict the outcome. Therefore, we are throwing it open to chance. If we could predict the outcome, we wouldn't play the lottery. So, this equation is a very beautiful one, by the way, and it's one that you should all try and memorize, even if you don't know anything about quantum mechanics. But just to stress this point, if you take an electron, if you think God moves in mysterious ways, rather, you should look at the way an electron moves, because that is very mysterious. But nevertheless, the electron's position can be characterized by a probability law. The electron doesn't just randomly decouple from the electromagnetic force and just fly off somewhere and write a book or something. It's completely operating on the laws of physics. It's just that these laws we have to express in terms of probability. They're not solid linear laws. And this demonstrates that the universe is, queerer than we can suppose, at least at this time. But what about the universe itself? Isn't it finely tuned? Isn't this a beautiful image? This was taken by the Hubble Space Telescope as an anniversary image. It's a part of the Carina Nebula, processed with the Hubble palette, taken with the new camera that they installed last April. And it's absolutely stunning. The universe is magnificently beautiful, even without instruments like this. Just going out and looking at the night sky yourself, it's absolutely thrilling. But the fine-tuning of the universe, William Lane Craig's first premise for his teleological argument, is a little bit confusing. We already talked about fine-tuning. We said it was something that a tuner does, a physicist, to his model to make it fit the data. Anthropic bias. You have to have a tuner if you use the phrase fine-tuning. But here, we just have clouds of gas that are operating on the laws of physics. Well, it turns out that this word, or in this context, the words fine-tuning are applying to the laws of physics themselves. This is something that I had to really track down, because it's not something that I was taught as a graduate in astrophysics. It was not something I was ever expected to know. It was not something that was ever considered to be particularly important. But now it's making the rounds on the web all the time, and as a denizen of the web, I come across it all the time. So it turns out that fine-tuning has its roots in speculative physics. Physics that has been proposed by real physicists on a speculative basis to try and grapple with the idea that nature acts with such precision. Martin Rees, who's an absolutely smashing chap who I've met only once in passing, really nice guy. He wrote this book, just 6 numbers. He followed it with another book called Our Cosmic Habitat, which is a very good book as well. But in this first book, he discusses 6 numbers, which are dimensionless ratios, which take so-called constants of nature, divide one by another or multiply some together, and you end up with these dimensionless numbers which he and others claim cannot be altered at all in the real universe. If whatever these numbers represent were to be altered in the real universe, in nature itself, stars wouldn't be able to form, humans wouldn't be here. So the universe appears, if you follow this line of reasoning, to be finely tuned, and as William Lane Craig explains it, finely tuned for the existence of intelligent life. Now this is kind of strange. I'm going to go back a slide here, just because that's a nicer picture. Finely tuned for the existence of intelligent life. What metric are you operating on if you think that intelligent life is the apex of the universe? Intelligent life is pretty cool. I quite like intelligent life. I think it's certainly quite special, but it's not, doesn't seem to be the most, I don't know, doesn't seem to be a great surplus of it in the universe. There are more stars than there are people in the universe. There are more stars than there are grains of sand on the surface of the Earth in the visible, known universe. So how can we possibly say that humans are necessarily above stars or empty space? There's a lot of that in the universe as well. There's a lot of neutrinos, the most abundant particle in the universe, it appears. Maybe the universe is fine-tuned for the existence of neutrinos by the god of neutrinos. And we're just some happenstance accident that came along and screwed it all up by trying to detect them and find out what they were. Well, These theories, these speculative theories about fine-tuning, have been kicking around for a long time, and it's only recently that theologians have really started to grapple with them. It turns out that if you do divide various constants to produce these 6 numbers, you can show that nature acts with extraordinary precision. Because if you tweak one of these numbers by 1 part in the 10 to the 100 millionth power or something, then everything falls apart. And that's kind of important. Nature does act with extraordinary precision. But I think it's important to recognize that these numbers are just things that we have invented. They're just numerical values for something beyond in nature. We don't know what they are, we just give them labels. And it's led me to believe that William Lane Craig doesn't understand the difference between fine-tuning and fine-tuning. Now, I just want to go ahead and state categorically why I don't believe in fine-tuning, or why I don't find the fine-tuning argument convincing. To say that fine-tuned parameters in physical models indicate fine-tuned parameters of nature is to say that those models are 100% perfect mirrors to nature. But they aren't. So, I think natural precision might be a better word for what Rees is describing. In fact, I think scientists like Rees and others have very haphazardly used the phrase fine-tuning in such a way that it actually obfuscates the true meaning and allows these sort of fine-tuning arguments to surface where they're not really needed. I think that Rees has not done so intentionally. Rees is a scientist, and the conclusion of his book is to invoke some hypothesis that involves multiple numbers of universes, each of which receives a set of these numbers. The sets are completely random, and again, chance, necessity, not really sure. But then you can invoke the anthropic principle, which is the statement that we should find ourselves in a universe that's very conducive to life. That's all the anthropic principle is. It's a tautology, but it's basically a way of saying that, well, if you had 500 billion different universes and one of them is the correct one for life, we ought to look out and find ourselves in that one, because we wouldn't be in any of the others. Well, natural precision. We know our models are fine-tuned. We admit this. Scientists admit this. Fine-tuning is something that's done by the physicist. As I said, our world is crucially dependent on these precise parameters. But the parameters are just things that we see and add numerical value to. We distinguish them, and that's something that I'll get to. But first, we can't reasonably assume that the fact that we have to fine-tune models means that these parameters are mutable. We call them constants for a reason, because they stay constant, it would seem. But we can't really think of any way in which the speed of light can just spontaneously change its value. Not yet, anyway. Maybe we're just not being imaginative enough, or as imaginative as William Lane Craig, but I think if there's one thing Craig needs less of, it's imagination. As scientists, though, and as human beings, we compartmentalize facets of nature for simplicity, and that's okay. We're flawed. We like to do that. We like to take things and put them in different boxes and say, this is this and that's that. But aren't we really overcomplicating things? Well, some people would argue that we might be, and there's some evidence for it. There's a physicist in the States who writes for a blog called Cosmic Variance, and if you don't read that blog, you should. His name is Sean Carroll. And I'll read this one to you because I appreciate that it might be a little bit small for the people at the back. Beyond the fact that the constants of nature do not seem to be chosen by any intelligent agent, there remains the very real possibility that the parameters we think of as distinct, for example, the parameters measuring the strength of the electromagnetic and nuclear forces, are actually calculable from a single parameter underlying. The speculative proposal is the goal of so-called grand unified theories, for which there is already some indirect evidence. In other words, it might turn out that the constants of nature really couldn't have had any other values. He goes on to say, and I've included this for completeness, so you can't say I quite mind him, I don't think that if we discovered this to be the case, it would count as evidence against the existence of God. Only because I don't think that our present understanding of these parameters counts as evidence in favor of God. Now, whatever you might think about multiverse theories, they aren't actually just pulled out of someone's ass.